Welcome my dear students in secondary 1. Let's continue unit 1. Today we will study how to determine the types of roots of a quadratic equation. We studied before how to determine the degree of the equation. We said that the degree of the equation is the greatest degree of its terms. Here for example, we have an equation 3x plus 7 equals 10. The degree of this term is 1 and here 0 degrees. So this equation is from the first degree. The second one, x power 2 plus 2x minus 9. We have 3 terms. The first term, second degree. The degree is the power of the variable. 2x power 1. So we have second degree, first degree, and here 0 degrees. So the greatest is the second degree. The third one, I have x power 3 plus 2xy minus y power 2x power 2. So the first one here, the first term from the third degree. The second term, second degree, 1 plus 1. And here 2 plus 2. So I have 4, 2, and 3. So I'll choose the greatest, which is fourth degree. Number 4, here I have 5, 2, and 3. So this is from the fifth degree. The last one, I have here the second degree and here the third degree. So this equation is from the third degree. The equation from the second degree is called quadratic equation. So this equation is an equation from the second degree in one variable. We studied before how to solve the quadratic equation in one variable. Algebraically, we can solve it using factorization or general formula, and also we studied how to solve it graphically by drawing the curve. By using the general formula, the general formula is that x equals negative b plus or minus b power root b power 2 minus 4ac over 2a, and a is the coefficient of x power 2, b is the coefficient of x, and c is the absolute term. So if we have any equation from the second degree in one variable or a quadratic equation, we can use this general formula to get the two solutions or the solution of this equation or the roots of the equation. We studied in the last year that if b power 2 minus 4ac is greater than 0, it means it is a positive number. In this case, we have two different solutions in the real number. We can get the two solutions or the two roots using the general formula. If b power 2 minus 4ac is equal to 0, in this case we have only one solution, a unique solution in R, negative b over 2a. If b power 2 minus 4ac less than 0, then there is no real solution. By drawing, we studied how to determine the number of solutions. If we have here we have the curve. Okay. In this case, this curve intersects x-axis in 2 points. The x-coordinate of each of the 2 points is the solution. So in this case, b power 2 minus 4ac is greater than 0. So we have two solutions. Here, for example, the curve touches the x-axis in L and 0. So the solution or the root is only L. And here there is no solution in R. The set of solution in R equals 5 because the curve doesn't intersect x-axis. Okay, today we will define the discriminant. What do we mean by the discriminant? The discriminant is b power 2 minus 4ac we studied before. Okay. The discriminant is b power 2 minus 4ac. If the discriminant is positive or greater than 0, in this case we have two different real roots. We say that we have two different real roots because the curve intersects x-axis in 2 points. Okay. If b power 2 minus 4ac equals 0, in this case we say that we have two equal real roots. They are the same, two equal real roots. It will be the x coordinates of this point, which is the intersection of the curve with x-axis, or the point where the curve touch the x-axis. If b power 2 minus 4ac, or the discriminant, is less than 0, in this case I have two complex and non-real roots. So because this curve doesn't intersect or touch x-axis. Okay, let's take this exercise. Determine the type of the two roots of each of the following and find the two roots. I'll determine the type of root, then I'll find the two roots. To determine the type of roots, I want to get b power 2 minus 4ac. Okay, here a is 1 because this is the coefficient of x power 2 is 1, b negative 7, and c equals positive 10. I'll calculate b power 2 minus 4ac, it will be 9. Okay, so it's positive. It means that we have two real roots or two real solutions. Let's take the two solutions. I'll use the general formula. Negative b, it means negative 7, positive or negative square root of the discriminant, which is 9 over 2. So the two roots are 5 and 2. Another exercise, I want to determine the number of roots, so I want to get the discriminant. Then I'll solve this equation. A here equals 1, b the coefficient of x negative 4, and c is the absolute term, which is 5. The discriminant equals negative 4. b power 2 minus 4ac equals negative 4. So I have two complex and non-real roots. I'll use also the general formula, so I'll get that the two solutions are 2 plus I and 2 minus I. Negative b, it means 4, positive or negative square root of negative 4. Square root of negative 4 is 4i. So 4 positive or negative 4i over 2, and I'll divide by 2, so it will be 2 plus I or 2 minus I, two solutions. If x power 2 minus 4x plus 5 equals 0, then prove that the two roots are complex and not real. Then use the general formula to get the two roots. So I'll get at first the discriminant, it will be less than 0. If the discriminant less than 0, it means that the equation has two complex and non-real roots, and I'll use the general formula to get the two roots. This exercise, find the real value of k, which makes the two roots of the following equations are equal. Okay, 4x power 2 minus 8x plus k, the two roots are equal. The two roots are equal, it means the discriminant equals to 0. So let's get the discriminant. I have here a equals 4, b negative 8, and c equals k. So b power 2 minus 4ac will be 64. This is negative 8 power 2 minus 4 multiply k. So 64 minus 16k. This is the discriminant. Okay, so the two roots are equal. It means 64 minus 16k equals to 0. I'll solve this equation. So the discriminant should be 0. When you solve this equation, you will get that k equals 4. 16k equals 64, so k equals 4. So k should be equals to 4. Then the 2 equals root will be negative b over 2a. Negative b, it will be 8 over 2a is 2 multiply 4, which is 8. So the two equal roots will be 1. Find the real values of m which satisfy that the equation x power 2 minus 2m minus 1 by x plus m power 2 equals 0 has no real roots. What do you mean by no real roots? It means that the discriminant is less than 0. Okay, a here equals 1, the coefficient of x power 2. b is the coefficient of x. It will be negative 2m minus 1. c is m power 2. I want b power 2 minus 4ac less than 0. So I'll calculate them. Here negative 2 minus 1, it means negative 2m plus 1. It means 1 minus 2m all power 2 minus 4 multiply 1 multiply m power 2 is 4ac. Okay, should be less than 0. Here first power 2 minus 2 by first by second plus second power 2 minus 4m power 2. 4 multiply 1 multiply m power 2, so 4m power 2 less than 0. Okay, so here we have negative 4m, positive 4m power 2 and negative 4m power 2 equals 0, so 1 minus 4m less than 0. It means negative 4m less than negative 1. Now I want to divide by negative 4. If you divide by negative number in inequality, it means that I'll change the inequality sign, so it will be 4m greater than 1. Then I'll divide by 4. Okay, at first I divide by negative sign. Now I divide by 4. It will be m should be greater than 1 over 4. So it belongs to the interval from 1 over 4 to infinity, because we don't have or equal. If you have or equal here, then this will be closed. Okay. Okay, we have a remark here. If the coefficient a and b and c are quadratic in a quadratic equation, ax power 2 plus bx plus c are rational numbers. If they are rational numbers and the discriminant is a perfect square, so you have two conditions: a and b and c are rational and the discriminant is a perfect square, then the roots are real rational numbers. Here, for example, if a, b and c are rational, a, b and c are rational numbers, prove that the two roots of the equation are rational. The two roots are rational if a, b and c are rational and at the same time the discriminant is rational number. So I'll calculate the discriminant at first. Okay, the discriminant here, b power 2, b is a power 2 plus b power 2. This is b power 2 minus 4 multiply a multiply c also ab power 2. Okay, so ab power 2, this is c, 4a, this is a. Then I want to simplify. We studied how to simplify this. First power 2. Okay, so it will be a power 4 plus 2 by first by second, 2a power 2 b power 2 plus second power 2, which is b power 4. Then I have minus a power 2 b power 2. Okay, here we have 2a power 2 b power 2 and negative 4a power 2 b power 2. It will be negative 2a power 2 b power 2. And this is a perfect square, which is a power 2 minus b power 2 all power 2. So this is a perfect square. It means that the roots of the equation are rational, because a, b and c are rational numbers and in the same time the discriminant is a perfect square. Okay, if the discriminant of the quadratic equation of a real coefficient is not positive, it means it is negative, so I have two complex and non-real roots. Then the two complex and non-real roots will be two conjugate complex number. It will be conjugate. It means if the first one is 2 minus a, the second one will be 2 plus a, and so on. Okay, so if the discriminant less than 0, it means I have two complex and non-real roots. The two complex roots will be conjugate. Okay, that's all about our session today. We studied how to determine the type of roots of quadratic equation. Next session we will discuss the relation between the two roots of the second degree equations and the coefficient of its terms. Thank you very much for watching. See you next session and goodbye.